All right. Thank you so much, guys, for coming. So today we are actually doing our last lecture for the midterm one, which is next Tuesday. It's integumentary system. We'll pretty much talk about skin, which is the major organ of the integumentary system, and then we'll talk about the other organs like nails, hair, and glands, but we'll mostly focus on the skin because it's actually the largest organ in the body also, and focus a little bit on the hair and some of the other organs. All right. I know you had kind of problems in the module about the growth stages of hair, so don't worry too much about that because I'm not going to cover all that much. We're just going to know the basic characteristics of hair, like the layers, the cuticle, the cortex, the medulla. And we're going to talk about hair insofar as it is involved in one of the major functions of the integumentary system, temperature control. All right? So don't worry about that. And then we'll cover some of the other structures, some of the other problems you had in the modules, like, the different skin cells, the epithelial cells, all right, in the epidermis, and also, starting from the bottom, going up from the basal layer, and how the cells change in shape and, function and characteristics. And we'll talk a little bit more about that. But the integumentary system, of course, involves skin and the other organs like nails, hair, glands, all right? And we mostly, and this is all epithelial tissues, remember? The tissues we did at the beginning. Skin covers, and that's what epithelial tissue does. And then also glands produce, like the sweat glands, are the ones we're going to talk about. We'll talk about two types of sweat glands. So the general functions of the integumentary system, because it covers, it's going to be protection, right? It's going to be protection against UV rays. In terms, that's where the melanocytes come in. Another item that was problematic in the module was, matching the skin cells with their functions, and so we'll kind of cover that, especially when we talk about the four skin cell types in the epidermis, right? So protection. So these will be melanocytes. All right, and prevents, of course, microorganisms from entering. What is the quality of skin that does that? The stratification, multiple layers. It's just a long way for the, bacteria to penetrate through, right? So strata. Strata is another way of saying layers. Strata, stratification, layered. All right. Prevents dehydration. What are the cells that are, this was in the module too, and a lot of people go to for the data. Yes, keratinocytes, that's very correct. I like those modules because when you get it wrong, it will tell you the right answer and then you know it. After that, you know it. So keratinocytes prevent dehydration. Why? Because they're full of the protein called keratin, which is dry protein, right? And another thing is that helps out with dehydration. With the prevention of dehydration is what else? What else surrounds these dry, flat layers in the epidermis? Oil? Oil? Oil and water will mix. So the lipids that come from those lamellar bodies after they burst, the lipids surround those cells and therefore retard water loss, right? So another thing is those lipids again that come from the lamellar bodies do that. All right. Sensation, of course, we're going to talk about Merkel cells, which are sort of star-shaped cells that are sensory in nature, and they pass the information to the neurons that take it to the central nervous system. So we'll talk about those, types of cells in the epidermis. Merkel cells, for example. And then you've got also bare nerve endings over there throughout the skin for pain and itching and things like that. All right? And then, of course, temperature regulation. So this is where we start talking about some of the other organs of the, integumentary systems such as temperature regulation. What are some of the other? One of them I just talked about it, which I said you shouldn't know too much about. What was that? Starts with an H. Starts with an H. What other organ of the integumentary system did I say at the beginning?
Hair.
Hair. Hair. And I'll show you how that is, okay? I'll show you how hair is involved in temperature control, okay? It's not intuitive. It looks like hair, okay, temperature, it doesn't match. But it will make sense in a bit. What else? I mean, of course, you know, the sweat glands. They are located in the skin. When you sweat, it evaporates, and then that's how you lose the heat. And then vitamin D production. All right, vitamin D production, you know, made up of, this is a fat soluble vitamin, all right? It is made up of a compound called 7-dehydrocholesterol. So the mother compound of this is cholesterol actually. 7-dehydrocholesterol, hence it's called vitamin D. And UV light, that's why you need to be in the sun to get some vitamin D, will make cholecalciferol, which is a precursor for vitamin D. That is then converted to vitamin D, active vitamin D, in the kidneys and the, the liver. And vitamin D is for
Bones.
yeah, bones in terms of calcium absorption, because vitamin D is needed for calcium absorption. All right. So by default, another function of skin, you know, because it produces the vitamin D that you need for calcium absorption, you know, which is very important in your skeletal system. So we get see calcium absorption. That's another function of skin that is kind of related, you know, but it is a very important one. And of course, excretion is a very minor function of the integumentary system. Sweat glands sometimes release just minor quantities of urea, you know, uric acid, ammonia, very small quantities. Ammonia in large quantities in solution is poisonous, so it's not even. That's why we avoid urea in urine. Okay, and a bit of salt. That's why your salt, your taste, your sweat tastes salty. If you ever went out a little bit and it goes into your mouth, you taste it. That's because a little bit of salts are also gotten rid of. But the excretion is really one of the minor functions of the integumentary system. Okay, so I'm already wanting you to start to get to associate the function with the cells that are doing it, or with the organ that are doing it. Because that was one of the things that was challenging in the modules, in terms of associating which part of the integumentary system is responsible for which function. Right? Okay, so skin, there you go. Surface area. It's about up to 2 square meters. So that's a lot of area. That's why skin is, the major organ of the body, the whole body. Of all the systems, skin is the largest organ of the body. And it's part of the integumentary system. It's about 11 pounds, 9 to 11 pounds in weight, right? So that's weight. And then, of course, there are 3 layers, but really there are 2 skin layers. Okay, so the epidermis is one that is those 5 layers, right? The corneum, the lucidum, the granulosum, spinosum, and the basal layer. Okay, we'll talk about those and the kind of cells you find there. And then the dermis is below that. It's got loose connective tissue and it's got reticular connective tissue. All right, and it's the bulk of the skin is the dermis. But under the dermis is the subcutaneous tissue, or sometimes called hypodermis. Hypo means under, dermis means skin, so it's under skin. So while we kind of sort of talk about it as one of the layers of skin, the hypodermis, the subcutaneous layer, is not really true layer of skin. But it's really important because it's got all that fat that insulates. Even thin individuals, they have some kind of fat, adipose tissue under their skin, because it's a good insulator so that you can maintain your heat and it helps with not losing. So the epidermis with those 5 layers and 4 cell types, and we'll talk about that. And then, of course, the dermis. How many layers in the dermis?
2.
2. The papillary and the reticular layer. Very good, thank you. In fact, the reticular layer is one that we scrape off the top, and the reticular layer remains to form leather. It's the tough connective tissue that gives skin its toughness, right, and the protective nature, right? And then, of course, so which forms about 80% of the dermis skin. Subcutaneous tissue, hypodermis, under skin, not really true part of skin, but it serves a very important function in terms of skin, so we kind of include it. All right. You got a question there, Rennie? No? No, you're good.
So on the test, yes. You asked the layers, would you only want the epidermis and the dermis, or would you want all 3?
I want all 3, you know, they're in terms of what they're involved in. You will find blood vessels, a lot of blood vessels, you know, in the subcutaneous tissue, you know. That's what supplies nutrients. Okay, and it connects, of course, the dermis or skin really to the underlying tissues like the muscles, right? So it's important. That's why we kind of include it, but we just have to give that caveat that it's not really true layer of skin. Okay, these are the 2, you know, and this has got 2 layers. Okay, so we'll talk about each of those. You see the skin, you see the hypodermis, you know, layer, a lot of adipose tissue there, which is really contributes to the major function of skin also in terms of temperature control. It prevents heat loss by insulation, right? And most of the blood vessels are kind of located right at the junction of the dermis and the hypodermis. All right. So we get the hair follicles here, and then the sebaceous glands, which open into the hair follicle. In fact, pimples and so forth, this is inflammation of that sebaceous glands. It gets filled up, and it gets inflamed with pus and so forth, and then you get the pus that comes out. Okay. And then the erector pili muscle, also involved in temperature control. We'll talk about that. That's when you're cold, you get goosebumps, right? That's when this muscle contracts and it creates that little bump. And then when it contracts, it causes your hair to stand up, to be more vertical to your skin. Okay? And when that happens, it traps a lot of air in between the hairs, and air is a good insulator, so you lose less heat. See, that's how hair is involved in temperature control. Okay? And we'll talk a little bit more about that later on. All right? The epidermis array with the 5 layers, and the dermis with the 2. Right, and you see these undulations into the epidermis, of course, the papillary layer, which jut out into there, and you can actually see those impressions of how the papillary layer juts into and out of, and we know them as fingerprints. Right? Fingerprints are very unique to each individual, and then we end up using them for identification purposes, but the major function is to give traction on your hands so that they're not smooth and, you know, and everything slides, to give traction. So the epidermis, those 5 layers, okay, is the most superficial, and the top layers are dead skin, flat, squamous, all right, and you know, they produce vitamin D, you know, and of course the hair is right on the epidermis. In fact, it's full of hard keratin. Okay, the top layer of skin is full of soft keratin. It's full of keratin which is dry, but it's soft, okay? But your nails, see how hard the nails are? They're full of hard keratin, right? Okay, and so it's a barrier that prevents, so, and it's all keratinocytes in there because they're so full of keratin, all right? And then, of course, with the ultraviolet light produces vitamin D. So the corneum, the most superficial, all right, and resist abrasion, all right, and the blood vessels are not present there, so you don't get any bacteria going into the circulation as well because they are further down. So that's another way it prevents microorganisms from entering, because the circulatory system is in the layers below. It's not like exposed on the top where bugs can get in. So that was kind of also in your modules, in terms of the functions of the skin. And then the lucidum, this is sometimes not present in thin skin, but thick skin, like on the palms of your hands and the soles of your feet, where the thick skin is, the lucidum is there. It's one of the 5 layers, but it's sometimes absent, and it's got this keratohalin and keratin fibers. It's kind of altered. Keratohalin is a protein that's kind of altered from keratin, and it kind of gives it a more fibrous and more.
So is the stratum that thick skin one? So basically, it's only present on your feet and your hands.
Yeah, for the most part, yeah. And some areas where your skin is a little thicker, but where might you have thick skin? Some of the other areas, like most of the areas that are covered, you might have it on the outside of your hands. You might have the lucidum on there, because this is really not thick as this one, but you might find it there. But in other areas, really, like most of the parts that you are covered, they don't have the lucidum. Yeah. All right. And then, of course, the granulosum, because of the granules, keratohalin granules. That's why it's called the granulosum. So the 3rd layer. All right. There's 2 to 5 layers. Produces keratohalin granules, and the lamellar bodies are the ones that are full of lipids, oil, right? And in the 3rd layer, the granulosum, we'll talk about it, and the lamellar bodies will burst, and then those cells will die right at the top of the top layers, the more superficial layers of the granulosum. Granulosum are dead, and they've dispersed their lipids out, so that by the time you get to the top, all the cells are kind of surrounded by lipids. All right. So we'll kind of talk about all these layers of and the stratum basal, of course, is the deepest layer, and they are cuboidal cells. Okay. And these are actively dividing. These are the ones that provide the cells that will replace the ones that will slough off. Because every 25 to 45 days, you replace your skin. All right. And this is the layer that provides those cells, all right? And they're also melanocytes. About a quarter of the cells in the basal layer are melanocytes that produce, melanin, all right? And we'll talk about how melanin also gets taken up by all the other cells of the skin, right? And then the dermis, the papillary layer, which forms the fingerprints because it has all those undulations into the epidermis, and then the reticular layer. Of course, it's reticular fibers, collagen fibers, and it's like a sheet which is very strong, forms the bulk of the skin, and then of course the subcutaneous, with the adipose tissue and so forth, and it's not really truly a layer of skin. All right, so we start with the epidermis, and there's the epidermis that is highlighted on the top, and what's on the bottom is an actual paragraph that just shows the outside layer of skin. All right, so the epidermis composed of keratinized cells, which are helpful in retarding water loss, and they are squamous, flat cells. Right? Start off cuboidal at the bottom, they change shape, and also they change chemical composition. And this was in your module as well. By the time they get to the top, they are full of keratin, they're dead cells, and they are flat, they are squamous. All right? Okay. It's got 4 distinct cell types which we'll talk about, and then we'll talk about what they do. All right? And for the most part, their function is really related to their, characteristics, like what they look like. And then, so we have the melanocytes, keratinocytes, Langerhans cells, and Merkel cells. Those are the 4. And each of them have a specific function, and we'll talk about it. And I want you to be able to, some of them, the name will tell you what it is, you know what I'm saying? Like keratinocytes, what's the function of keratinocytes? Yeah. Say keratinocytes. What's the function of melanin? Melanocytes. Oh.
To produce melanin.
I really helped you there. I gave you. Okay, you see, melanocytes produce melanin, so it kind of helps you out a little bit. So the outer portion of skin, of course, is exposed. Like we talked about, the epithelial tissues, there's an exposed surface, which is the apical surface, right? And because of the layers, it protects, from abrasions, physical damage, and also entry of bacteria. All right. Keratinocytes, like the name says, these are the most abundant, of course, because then all the cells are full of keratin, and they're dry and dead cells, and they slough off the top layers. Produce keratin, which is a fibrous protein called keratin. And you find soft keratin in the cells on the skin, very hard keratin in the nails. Right? So it gives the protective qualities, retards water loss, prevents dehydration. Melanocytes, of course, it's a sort of a brown pigment that produces melanin. Right? Actually, all humans have about 8 or so % of the skin cells being melanocytes. What differs in skin color is the size and the amount of melanin produced by those cells. Right? The fair individuals produce less melanin, and the darker individuals produce a little bit more melanin. Most of the dark individuals originated from Africa, where there's a lot more sun. So it's an adaptive nature, so that they get protected, because the melanin is for protection from UV rays from the sun. So in Africa, there's more sun, you know. So we pay for it a little bit by being darker, but we get protected. Okay, that's why skin cancer is less prevalent in dark-skinned individuals, more prevalent in light-skinned individuals, because they have less protection. Okay, so that's the way it is. You win some, you lose some. You know what I'm saying? Okay, so this is found in the deepest layer of the epidermis because it's, remember I said it's about a quarter of the basal layer cells are melanocytes. And the melanocytes, they grow processes that go all the way to the top, so that those processes are engulfed by endocytosis. Remember we talked about that. Endocytosis, and then the melanosomes, which are organelles containing melanin. That's how they then internalize into the other cells. All right? So, melanocytes. And then Langerhans cells, these are like the macrophages of them, like the immune system, really. So, if a bacteria were to enter in the macrophages of the skin, the Langerhans cells would actually start to attack it, for one, and then they migrate close to lymphocytes, white blood cells, and activate them, because the white blood cells are really meant to do that, macrophages. Okay, so these Langerhans cells activate the immune system by migrating. When they come across bacteria, they migrate towards white blood cells, and then the white blood cells become excited, and then they start to attack. Okay, so Langerhans sort of immune part, which falls under what? Under what quality of the skin? What major function of the skin? Protection. Yes, protection. Okay, protection. So because remember again, I want you to be able to associate the cell type with the function, right? With what function of the cell, of the skin it is. All right. Okay. So Merkel cells, these are sort of spiny, sort of star-shaped, almost shaped like neurons with the kind of sort of dendrites or little processes from the cell body, and that allows greater surface area to sense all the way around the cells. So they are sensory, and they pass the information to neurons. All right. So Merkel cells touch receptors. All right. So when you touch your skin, the Merkel receptors will be. So they are mechanical receptors. Right? Mechanical receptors. All right. So this is sensory. Okay, Merkel cells. So those are them, the 4 skin cell types in the epidermis. We're just talking epidermis right now. Okay, so we're still talking epidermis. Now we're going to talk about the layers of the skin. We started from the bottom, where we have the basal layer, those mitotic cells that are really dividing up. Then we go to the spinosum, then we go to the granulosum, then we go to the lucidum if it's there, and then we finish at the corneum, which is so called because the cells are conified, they're full of keratin, and they're dry and dead. So this is the deepest layer. These are the most live cells. They're the closest to the nutrients, right, from the dermis. And they're actively dividing, and they provide the cells that will eventually replace the top cell layer that when it sloughs off, which is about every month. Okay? Remember we talked about those cell-to-cell connections. the basal layer, of course, is the basement membrane, then the dermis starts. And then, so the basal layer is connected by hemidesmosomes to the basement membrane, and then the cells, of course, are connected by desmosomes. All right? Remember, we talked about the desmosomes being like areas of strong connection, or like a spot weld, where you kind of have strong connection between the cells. All right? So we know about this already from when we did those tissues. All right? So these are the youngest keratinocytes, and they're actively dividing. And they're the ones that will replace the keratinocytes on the top eventually. And then later on, we'll talk about how the progression from the cuboidal keratinocytes in the basal layer to the squamous flat cells in the, in the stratum corneum, all right, and surrounded by lipids. So we're changing cell shape, we're changing chemical composition of the cells as well when we do that. All right, so like I was saying, about a quarter of them are melanocytes that produce melanin. So the melanocytes are on the bottom, and I'll show you again how the melanin then permeates all the cells, all the cell layers on the top. All right, okay, so because they're processes that grow from the cells, or extensions, cell extensions that carry the melanosomes up and snakes their way between the cells, and then those cells will engulf it, parts of those processes to internalize the melanin. So spinosa is the next layer from the bottom, and starting from the bottom going up. Like the song, started from the bottom, now we are. Drake, you know what I'm saying? Okay, so stratum spinosum also kind of like the limit of the nutrients a little bit. Okay, so melanin is taken up by these keratinocytes and accumulates on the sunny side, because the sunny side is the apical, what would be the apical surface or the cell, the most superficial layer is what we're calling the sunny side, because the most superficial layer is one that's exposed to UV light, right? So that's where melanin is going to stand and wait to protect against UV. Okay, so so protects the nucleus from UV damage, because the UV light can cause mutations in our DNA. And that will deal with that, because then you won't be able to produce the proteins with proper function, right? Stratum granulosum, it's called granular because of the keratohalin granules that start to accumulate, right? Keratohalin granules, so it's called granulosum. And then also the lamellated bodies will start to pop. In fact, on the superficial layers, because it's about 3 to 5 layers, okay, of cells in the granulosum, and they start to, they're kind of diamond shaped. They're approaching that flat, because they start to cuboidal, and then they kind of start to flatten out. So these ones are kind of diamond shaped. All right, because after that, it's like you're taking the cube and you're spreading it like that. That's how you form a diamond. And then by the time you get to the top, it's now flat. It's now nice and flat. All right. So the lamellated bodies for waterproofing. Why? Because they contain the lipids. And then in these upper layers of the most superficial layers of the granulosum, they will burst, and then the cells will die. All right. And then the lipids will start to surround the cells in the top layer, again to retard water loss. And once the lamellated bodies pop, the cells die. And those are the superficial layers of the granulosum, because it's got 3 to 5 layers, right? So the most superficial ones that are most on top, those ones are now dead. We're beginning to really die. By the time we get to the next layer, they are really dead cells, now full of keratin, surrounded by lipids, right? So, and I'll show you a diagram showing how the cells are changing, going up in terms of chemical and structural composition as well. So, that lucidum is one we say is sometimes not there, especially in thin skin, but it's present in the thick skin, and the palms and the soles of your feet, right? Then it's thin and transparent, it's superficial to the granulosum because it's above the granulosum. All right. You know, so it consists of a few rows of flat dead cells, keratinocytes. Okay. Whereas the granulosum is more diamond shaped. Okay. It's like taking the cube and starting to stretch it. And then, you know, present only thick skin, like the palms, definitely, and the soles of your feet. All right. For protection, really, your hands are handling and touching everything. Your feet. Back in the day, they didn't even have shoes. You know, they just went barefooted. So you can imagine, you know, very thick shoes, almost like you're wearing heels, you know, because your skin is so thick. You know. So stratum corneum it's about 20 to 30 cell layers, very flat cells, full of keratin, surrounded by lipids, and also by the time you get to the granulosum, the cells are now, you know, surrounded by a very tough protein on just under the plasma membrane of those cells, making them even tougher. And then they're full of keratin. Okay, that makes them very tough and dead and dry. So provides, you know, prevents water loss. All right. So look at this. Millions are rubbing off every day, millions of cells in your skin. Okay. Especially when you go to bed, you know, you've got your nice new sheets in there, and you know how you turn in bed. Depending on how much, you know, most of the time you are rubbing off your skin cells in there, and your sheets may look like they're clean, right? Not dirty, but they got there's a bunch of sloughed of skin cells. So you gotta wash them every week at least. You know. If you're Oprah, then you change every night, you know. Because actually they have money. Okay, so waterproofing, because they're dry, they are full of keratin. Protection from abrasion, okay? You know, so if cuts and so forth. Some of the cuts, if they're not deep enough, you don't even bleed. Because, you know, but if it's deep, then you can start to bleed. But some of the cuts you can even go like, especially on the thick skin, it doesn't bleed. Most of the time you see little cuts on your, but they never bleed. Okay, it renders the skin relatively sensitive to biological chemicals, so that you're not a sponge. So if you dive into water, you're not absorbing the water through it, which is the kind of skin that frogs have. Frogs are like roots, actually. When they go deep in the ground, that's how they absorb water. That's why they can live in deserts. Like a root, they absorb water because their skin is, but ours is not. You know, we don't absorb like that. Okay, so that's what it does. Okay, so this is what I was talking about, where as the cells move up, they're changing in chemical composition and structure. Okay, so here we got the granulosum. You see our desmosomes over there, our heavy desmosomes over here, connecting the stratum basal to the basement membrane. All right, a quarter of these cells will be melanocytes, and I'll show you another diagram where the melanocytes are located in the basal layer, and they're growing processes to spread the melanin to the other cells. All right, so you got those actively dividing, all right, by mitosis to produce the cells that eventually will replace the ones that have sloughed off on the top. All right, and then in this stratum spinosa, they are beginning to produce keratin fibers. All right, and lamellar bodies accumulate. Lamellar bodies are full of lipids, and of course, keratin fibers are being formed in the second layer. Right? We still have kind of cuboidal shapes, cells, okay? Because these ones are cells that are producing. Remember when we talked about the glands and so forth, and we said glands that will release something or produce something tend to be cuboidal because you need the volume to create all those things. See what I'm saying? So these cells on the bottom will be cuboidal. So if I talk about the change in shape, the change in chemical characteristics of the cells as you go to the superficial layers, you talk about the cell shape and you talk about how the bottom layers are more cuboidal because you need the volume to produce the kelatohyaline and the keratin fibers and the laminated bodies and so forth, the lipids. So we're still kind of producing over here and see how cuboidal the cells are for volume. By the time we get to the granulosum, the keratin fibers we produce, we kind of combine them with some sort of collagen fibers, making it keratohyaline, which is more fibrous and stronger, and then they get enclosed in granules. They're sort of granulated, so that's what gives it the granular appearance. It's called the granulosum, right? And then, of course, the laminated bodies will start to pop as well. And this time, you see the cells are more diamond-shaped. You see, because these are not doing too much production. They are just taking all those lamellar bodies, just popping them, and then just adding a little bit of collagen to the keratin to make it keratohalin. You know, like from hyaline cartilage, right? Keratohalin, and that's what forms the granules, and the cells are now diamond shaped, right? So this is diamond shaped cells. Here it's cube, okay? And we got keratohalin over here. This is keratin fibers and lamellated bodies, and the keratohalin and the fibers of lamellated bodies have popped. The lipids are now exposed in the granulosum, okay? By the time you get to the top granulosum, they're kind of dead cells now, you see, these ones on the top, it's 3 to 5 layers. And the lucidum, it just has dispersed keratohalin, right? And it's sometimes not even there sometimes, all right? Okay. And here, they are now full of keratin, the cells surrounded by lipids from the lamellated bodies for waterproofing again, okay? So you see how it's changing up in terms of structure and in terms of chemical composition, all right? Keratin, lamellated bodies up to here keratohalin. We've kind of altered the keratin a little bit, and then the lipids have popped. The lipid sites, the lamellated bodies have popped, okay? And then here keratohalin that is dispersed a little bit, and it's a thin layer anyway, sometimes not even there. And then the top are full of keratin, okay? And surrounded by lipids. And the proteins here in the third granulosum, in the granulosum layer, they also get surrounded by that hard protein coat, just under the plasma membrane, okay? So that they are even harder, okay? So there's going to be a hard protein coat down here, like that. And then inside, of course, you have the granules, right? So that's that. Okay, very good. So I want you to know this. This was actually a little problematic in the modules. Know how the cells are changing shape, know how the cells are changing in chemical composition as you move to the superficial layers. From the deep stratum basal, and we're still talking epidermis, we just did the epidermis. We haven't even touched the other. So thick and thin skin, of course, the thick skin has lucidum on it, stratum lucidum, which is the 5th layer of the epidermis, okay? And it's not found in the thin layer. And hair is not found on the thick skin, right? Have you ever seen palms with hair on there? So you never find hair there. And you never find hair, unless if you're a baboon or monkey or something, they can fare, they can go all over the place. So, and you can begin to see some problems that hair would cause on your palms, right? A lot of problems. You can't feel properly because the hairs cannot locate the way, and you use your hands to manipulate stuff, to feel things. That's why people who are blind can do this with the braille, they can read. If you had a bunch of hair on it, forget about it. You know, you won't be able to feel. So you never have hair on the thick skin, okay? But you do have a whole bunch of sweat glands, though. If you notice when you're nervous or frightened, what happens to your hands? They become sweaty and sweaty palms. You know what I'm saying? That's what you have a lot of on the sweat glands. I guess because it's thick skin, it really keeps all the heat inside, so you kind of need to lose heat over here. Makes sense, right? But the side effect is that, you know, when you're nervous and your hands are kind of sweaty, it's not good. You know. All right. So melanin. Melanin is of course responsible for the skin color. It's pigmented and brownish, dark. Okay. It's produced by melanocytes, which we said are present in which layer are the melanocytes present in? Which layer of the epidermis are the melanocytes present in? Second cornea? Which one? Deep. Go deep. No, go deep. You're going to go through all of these cells. The basal layer, remember, a quarter of the basal layer are melanocytes. Okay? So that's where they are actively dividing, okay? Those cells, okay? Don't forget, guys, don't forget, okay? These melanocytes are in the basal layers. All right? And I'll show you how the melanin goes to the superficial layers very soon, okay? There's a nice diagram that I'm going to show you. And of course, You can alter the melanin production by tanning, like the fair individuals they like to tan. When they do that, because they force their body to produce slightly more melanin, because they're trying to protect themselves from the UV light from the sun, so they get darker. Okay. Some of the whites who are indigenous to Africa, they can't have a darker skin tone because they are tanning whether they like it or not. They just go outside, you know what I'm saying? And they start to tan. There are other ways that your skin color will change too, especially you know, when you're cold or when you're hot. When you're hot, normally you get flushed. That's because your blood vessels become more superficial, and blood is one that's really killing all the heat. And then when they're more superficial, then you lose more heat. So if it's cold, you become ashamed, you become like a ghost. Have you noticed that when you're cold or when you're frightened, because your blood vessels go inside, where they will lose less heat. So that's why it happens when you're cold. Okay, and when they are exposed to the outside, it's called erythema. And I'll show you a diagram where you can see the blood vessels will actually expand and they're more superficial. And that's what gives you the color. Because the blood is red, you become a little red. If you're working out, you're flushed, sometimes you become a little red because of that, because you're trying to lose more heat. Okay? So erythema is increased blood flow to the surface when the blood vessels expand and you lose more heat that way. And another way you can change skin color, okay, is when you have less oxygen content in there. And it was in the module too, when we was talking about change of skin color. It's called cyanosis when that happens. And kids turn blue if they're not breathing properly and stuff. You know, mothers, you know, they know about that. You rush your kid to hospital because it means they're not getting oxygen. Then their skin is turning bluish. So that's cyanosis, and that's another way skin color can be altered. Right? And the more melanin you have, or the bigger the melanin granules that you have, the darker you are. That's the genetic way of altering skin color. These are other ways that happen. Some of them are physiological, like erythema and blushing as well. When you see a boy you like or a girl you like or whatever it is, you know, you blush. That's because your blood vessels become exposed on the cheekbones, and you know, you blush. And it's an example of erythema. It's a physiological way you can change skin color. This is also physiological in terms of loss of oxygen. Right? So you can talk about the different ways you can change skin color, right? We know that everybody's got 80% melanocytes, dark or light, doesn't matter. It's just the amount that you produce and the size of the granules of the melanin. That's how it determines your
What
skin color.
about fair people who, even when they're in the sun, they don't really get tan?
Some people have less melanin production. Some of them have none at all, like albinos. Yeah, so those people, you know, they may not have active melanin production even when it's activated by going out into the sun, and they have a hard time tanning. Maybe they have a little case of albinism, you know, but albinism is like the total lack of, you know, production from the melanocytes. Okay, where even dark-skinned albinos look just the same as light-skinned, fair-skinned albinos. Except maybe the features of the skin will be different and everything else in the hair. Okay? So, anyway, and they even get blue eyes and all those things, because the blue eyes means the least amount of melanin is present, you get blue eyes. Green is a little bit medium, and then gray and brown again, you've got a lot of melanin. Okay? So, gotta know the different ways in which you can alter skin color, physiologically and genetically up here. Okay? And then this is another way you can do it by tanning. Okay, so and then another one is ingestion of food items that contain pigments like keratin from carrots. You know, you can get a kind of yellowish appearance of the skin. Or another one is hepatitis. Hepatitis causes jaundice. Okay, because of the metabolism of bile pigments like bilirubin in them. If the liver is not working properly, it's not going to, you know, metabolize those pigments properly, and the pigments are deposited in blood, and then you appear yellowish. Okay? So that's another way. So there's many ways you can alter skin color, all these physiological ways. Okay? And hepatitis, I think this was also in in your module when they talk about ways you can alter skin color. So hepatitis does that because it impedes or it disturbs the function of the pigment, metabolism. So keratin as well, the keratin one. Okay, so there's many ways you can do that. And this is how the melanin is spread out to all the other cells, all right? You see the melanin, the melanocytes, they are very much at the bottom, the basal layer, and you see how they grow processes like this, and these red dots there are called melanosomes. They are membrane-bound organelles containing a whole bunch of melanin in them, so they're called melanosomes. Just like lysosomes carry enzymes in them, okay? Melanosomes carry melanin in them. And then they grow up between the cells because they are in the deepest. So when these cells come across these processes, they will engulf by endocytosis like that. And then it becomes internalized. Okay? Remember endocytosis? When all these are pitched off and then they're engulfed. And then that's how each of the cells, because all the cells have to have melanin, especially the ones on the top. Because those are the sunny side, actually. Because it's the one that's exposed, right? So, so the melanosomes grow processes, and then the epithelial cells will phagocytize them, to internalize them, and then the melanosomes will be contained in those fragments that were pitched off from the processes, and then they're now internalized.
So someone who has vitiligo, does that their body just stops producing melanin in those areas?
Okay, I think maybe vitiligo may have to do with this process too. So, because they may be producing melanin just fine, like Michael Jackson claimed to have,
My stepmom.
Yeah, what's that?
My stepmom.
Yeah, and
She's
it's a real
so
condition.
she's really dark.
Yeah, she's really dark, but she's got patches. Yeah, so
and they're like white, like that board.
exactly. Because it would like be devoid of melanin. So maybe this process, maybe the melanosomes are not growing the processes properly, and therefore, if they don't grow the processes properly and they go permeate through all the cells, there's going to be some cells that are not going to be able to engulf them. But they're producing enough though, and then the other melanin gets packed in other areas because that's where those cells are engulfing it, and they're getting too much of it, and then they become dark. So probably that condition has got to do with these processes and the way they grow and they permeate throughout all the skin to distribute the melanosomes. Yeah, that's a good one. You see what happens with the physiology? That's why everything has to work out just right. But it's just the right amount, and it just gotta go to just the right shape, and it's gotta go to the right areas. And all that is happening. That's why the brain that controls. So know that process, okay, of how the melanosomes or melanin is spread out throughout all the layers of the cell, of the skin. We move on to the epidermis. The dermis, which is the second layer, okay, of skin. The dermis, and the dermis is the second major, region of the skin. It's strong, it's flexible, right? Because of those collagen fibers, the reticular collagen fibers, and the connective tissue. Remember we talked about how connective tissues, remember last time, it's flexible and it's strong, okay? Cell types, we get fibroblasts. Remember the blasts, they make the matrix for fiber, that all these fibers, reticular fibers are located. And then there's adipose tissue and macrophages, okay? That will, again, deal with bacteria, okay? If it gets in there. So you left out some macrophages. And the macrophages in the epidermis, what did we call them? Start with an L. Langerhans cells. Okay, guys? So gotta remember those. Okay. And then, of course, we have the two layers. The papillary layer, I'm going to show you how it's involved with the fingerprints, because it has those ridges that will undulate into and out of the epidermis to form the fingerprints, which happen to be unique. And in each individual, those fingerprints are unique. Even twins, identical twins, they have different fingerprints. So you can catch the one who did it. Okay? Because each one is got their own pattern. Okay? you know, but the real and the reticular layer is the second with connective tissue. So, so the papillary layer kind of goes into and out of. It has ridges. That's why it's called papillary layer, because of the dermal papillae that go into and out of the. So they make those ridges which then form the fingerprints. All right. Its superior surface contains this peg-like projections called dermal papillae, like this. So it goes like this, like that, like this, like that, and then the dermis the epidermis is kind of follows it like that, and then these ridges, you see, these are what forms the fingerprints. All right. So that's what's responsible for the fingerprints, and they happen to be unique for each individual, even identical twins. And now we use them for identification of criminals, but that wasn't the intended purpose by God or whoever created us, depending on your beliefs. But they're for trash, to create some grip in your hands. All right. So contains blood vessels, of course. Okay. Contains blood vessels. So they've got nutrients, and this dermis provides the nutrients to the deeper layers of the epidermis. You see what I'm saying? Because there are no blood vessels in the epidermis. Okay. And remove waste products, aids in regulating body temperature. Okay. In terms of the thickness, okay, which covers. In winter, you put on a bunch of blankets, right, on top to cover more, so you lose less heat. Same thing, like the thickness of the epidermis also helps with temperature regulation because it covers and it will prevent heat. Yes.
So do people in colder regions develop thicker skin after?
The people in colder regions, I think one of the adaptations they have is just the lighter skin tone. They are cold, but I think their dermis is on average maybe slightly thicker. It could be in terms of that adaptation. Yeah, that's good thinking. So it might be slightly thicker, you know, than individuals where it's kind of warm. Yeah. Okay. But it has to have a certain thickness, because the thickness of it is really for protection too. Okay, to protect so that you don't get. Because if it's not a certain thickness, then the protection goes too weak. So all the individuals may have, you know, kind of like the rough, equal amount. Okay, equal thickness, but it's possible they may have it thicker. It is. Okay. But temperature regulation, because there is other structures like hair and things like that, you know, muscles shivering that control temperature. So it's not a critical, you know, temperature control. So in that case, then, you know, it may not differ that much with people who are in the cold and people who are not, because there are many other ways you can deal with temperature. But it does affect the temperature in that sense. And there is some truth to the fact that it may be thicker in those individuals. It makes sense. So layers of the epidermis, of course, the reticular. We just talked about the papillary layer, which forms those undulations, and it provides nutrients to the dermis, to the epidermis, and it takes waste away as well. Okay. This one here is under the. What's that?
Oh, no.
Oh, okay, good. So the reticular layer is dense, irregular connective tissue, because it has to be strong in each direction. So the reticular fibers are all over the place. So that you put it this way, skin is strong. You put it that way, skin is strong. Okay, so that's why you have fibers that are oriented in different directions. So that's where you have the reticular. So accounts for 80% of the thickness of skin. So most of it, you know, so you can see that it's gonna have kind of same thickness there, Maria. You know what I'm saying? Because it's kind of 80% of your skin is gonna be just the dermis, reticular layer of the dermis. All right? Kind of like that 80% of melanocytes in every human being, regardless of how dark or light you are. Okay? So collagen fibers, of course, add strength to it, resilience to skin. Okay, and then the elastic fibers, which when you start to get old, they start to diminish, and then what happens to your skin when you don't have elasticity and stretch? You wrinkle. And then that's why at the end we talk about the effects of aging on the skin. All right? And then there's this striae, which are stretch marks. What happens is that when the skin is overly stretched, what happens is that the epidermis breaks, and the dermis on the bottom pops up like that, and creates those ridges that cause stretch marks. That's why you kind of see it in pregnant women a lot, because or people who were once very big and then they're now smaller. Sometimes they may have to take off additional skin, like the Biggest Loser. You know those guys, because you have a lot of additional skin once you lose all that weight. But pretty much you've got. I'm just drawing it flat, right? And then you've got your dermis on the bottom here, and this is the epidermis. So if you stretch this, and then you get a gap, and then this goes up like that, the dermis. See what I'm saying? And then that's how you form the stretch marks, called striae. All right? These are the marks when the dermis ruptures, when it ruptures up into the, and the reticular layer, while the fibers are oriented in all the directions, there's a certain kind of prevailing direction that the skin will take. Kind of here, if you look at yourself, or sometimes if you put it together, you can see some lines that kind of go on your skin. Okay, those are these lines we're talking about, the lines of cleavage or tension lines. They're very important when you're doing surgery, like when you're cutting, a certain area. If you cut against the lines of tension or cleavage lines, then when you suture it back up, you get popping, and and it won't heal properly, and you will have a bigger scar. But if you cut along, say like cutting along the grain, okay. If you ever done woodwork, if you are planing the wood, I don't know, you've got to go against, you got to go with the grain. If you go against the grain, you get bumps like this. It won't be smooth. Some of you may not know, but it's okay. But
when you're sanding it.
I did woodwork, yeah, when you're sanding it. I did woodwork when I was in high school, so anyway, that's okay. But it's the same deal. So you've got to cut along, if you're a surgeon, you've got to cut along the tension lines. If you're a very careful surgeon, some people don't care, some surgeons and some doctors don't care, and then you get a scar there, and the wound will pop. You see what happens if somebody is cutting across these tension lines? The incision will heal, but it will pop like that, because the tension lines are pulling the skin down. But if you cut along it, and then there's some people who are gifted and will say, oh, this surgeon is really good, my thing healed, no scar. The scar is really, it's because of this. So tension lines, lines of cleavage, is the orientation of the reticular fibers, kind of sort of goes in one way. And there's a map for it, and surgeons who are careful kind of know it, so that to avoid cutting against it. All right. So, and these are the result of the epidermis. I mean, the dermis, the reticular layer of the dermis. All right, and then the subcutaneous tissue, you can see on a cadaver, you're cutting deeper and deeper and deeper, and then you're getting to the adipose tissue. You can see the blood vessels are mostly located there, so they're bringing all the nutrients. That's why you kind of include it with the other layers, the true layers of skin, which are the dermis and the epidermis. Subcutaneous tissue, it's deep to skin, so it means it's under the skin, right? Remember those directional terms we did, composed of adipose tissue, areola, which is like loose connective tissue, right under there, kind of like a filler, and then a little, and it's not really a true layer of skin, but it does serve an important function. And it's mostly adipose tissue. And we talked about how it's also involved in insulation, all right, which is one of the major functions of skin, temperature regulations, because the reactions in the body go optimally at 37 degrees C. So if the temperature is wrong, then all the reactions in your body are not going optimally, everything. Okay? So, and that is problematic. So that's very important, just maintaining your temperature. All right? And then, of course, stores fat. I mean, if you're bigger, you have more of the subcutaneous tissue under there. All right? Under the muscles. And if you lose weight, so when you lose weight, that's why guys with more muscular, they tend to have more veins popping out, because that subcutaneous layer where the blood vessels are located is kind of less, and so you see, you know what I'm saying? So, what's that? Shock absorber. It's a shock absorber is an insulate, all right? okay, because it's fat, and most organs also have surrounding fat, like the heart, the kidneys, and so forth, adipose tissue to cushion and protect. Increase greatly, yeah, I mean, if you gain weight, so that's what happens. So hair, again, hair is all over the place. In females, the hair tends to remain vellus hair, because what happens is when you are young, when you are in utero, you have lanugo, which is like fine hairs and so forth. And then when you are born, that lanugo turns into terminal hair, especially in the eyelids. So it becomes terminal hair, which is real hair. Okay? And then some of that lanugo turns into vellus hairs. And vellus hairs are kind of light, some of them are almost invisible. So females will have kind of vellus hair throughout their skin, because females are not as hairy as men. Men, that vellus hair turns into terminal hair, actual hair. You know what I'm saying? Because terminal hair is actual real hair, and vellus hairs, and lanugo is even less. But vellus hairs are kind of, transparent. You can't really see them. When males turn bald, like myself, because of testosterone and so forth, it becomes vellus hair, and you can't really see it. It grows, but you can't see it. But I shave all of it off anyway, so that But so that's what the vellus hair is. It's kind of transparent hair, but males have it throughout. So that's why at puberty you start to boys, they will have the vellus hair, which is transparent, and the women that reach puberty and they get more testosterone, they become terminal hairs. So you get terminal hairs here and terminal hairs on the pubic area and so forth, right? So the hair above your skin is the shaft, and what's below is the root, right? It's got the medulla, which is the inner layer of hair, and then it's got and then the cortex, which forms the bulk of the hair. I know some of this deal was in the module, but don't worry too much about hair. I want you to just know it in so far as it's involved in temperature regulation. And then the cuticle, which is a slick layer of kind of overlapping cells on your hair. And so this is the bulk of it. So those are the three layers. Okay. And the hair bulb at the bottom, that's where the cells are actively dividing in the medulla, and then they're providing the cells that will then grow the hair. All right. And it's got growth stages. Hair is growing for a few years, 3 or so, and then rest for about 2 or so years. Okay. But at any one time, about 90% of your hair is in the growth phase. Okay. You lose a bunch of hairs per day too, and then they get replaced later on. And then, of course, the erector pili muscles. Remember that muscle creates goosebumps. The hairs are involved in the temperature regulation, because when you're cold, that muscle will contract and create what's called goose flesh or goosebumps. That's because the muscle is contracted and it bunches up. And then it makes your hair stand on end. And that's how you are able to trap air, a quart of air on your skin, which reduces hair loss. All right? Okay, so hair is associated hair follicles with the sebaceous glands, right? And then inflammation of those glands is what gives you the pimples, right? And the shaft, you can see that, and then the 3 layers, all right? Medulla, cortex, and cuticle. So sebaceous glands, we talk about them because they are also involved in production of sebum, all right, which is oil. It's natural oils. Again, to retard water loss. Okay? Whenever I come here, I always talk about how if you take a shower and you don't have time to put lotion on, you're sort of kind of whitish in appearance or whatever. Your skin is looking dry, and after a while, after you sweat just a little bit, you produce your own sebaceous glands will produce deposits of oil. See? That's why when you're starting to sweat, you start to glisten, like probably me right now. Okay, because I'm moving around. Just because of the oil that you're producing from the sebaceous glands. Okay, and of course, it's not going to be on your palms, right? For obvious reasons. Right? You've gone to the extent of making fingerprints to create traction, and then you're going to put sebaceous glands in there to produce oil. It doesn't make sense. So it becomes too sleek in there, you can't get the function. So you don't have them there. Okay? Okay, and then, you know, it creates that sebum that softens the skin and so forth. Sometimes it's stimulated by hormones, all right? That's why when you reach puberty, what happens? You start popping with disease, right? Because the testosterone and all those estrogens that are stimulating the sebaceous glands, causing them to become inflamed because they're producing too much, sebum, and they get blocked, and then that's why you get pimples at puberty, because the hormones are stimulating the sebaceous glands, right? And then secrete oil called sebum, right? And these are what kind of glands? Holocrene, because they secrete the whole cell and then it pops, right? Remember when we did glands? So acne is because of this inflammation, and acne starts at puberty because it's these are stimulated by steroids, testosterone, estrogen. So you get the puberty. And sweat glands, there's 3 different kinds. The actual sweat glands that produce sweat, of which there's 2 types, and we'll talk about it. And then the mammary glands are modified sweat glands, okay, that produce milk. And those are apocrine glands because they secrete partial products of the cell, partial portions of the cell. And then, of course, the sebaceous, the ceruminous glands in the ear that produce, these are kind of sort of altered sebaceous glands that produce earwax. Okay? Earwax, ceruminous glands, and so they're all sweat glands that have been modified some, okay, from the regular sweat glands. We do have, like, what, 3 million sweat glands throughout, and there's 2 types. Most of your skin is what are called merocrine sweat glands. These, they have their own duct that leads to the surface of the skin and will, provide copious amounts of sweat, okay? But then there's another type of sweat glands called apocrine sweat glands, okay? Because they produce an organic compound and they deposit onto the hair follicle. They don't deposit to the surface of the skin. They deposit onto the hair follicle so that bacteria will digest them, that organic compound, not sweat, and produce body odor. So that, and you have them in the armpits. That's where you produce body odor. Most of the time, when you put your roll-on, you don't put it on your chest. Because that's where all the apocrine glands are located that are producing the body odor. Okay? So, and apocrine glands are also found in the groin area, and they, in certain activities like sex, they produce a certain smell that is associated with sex. You know that? So that's the apocrine sweat glands, right? So they produce body odor, and in physiological situations like sex, they also produce a certain odor that's associated with sex. And then ceruminous glands, of course, are modified. Sweat glands that produce cerumen, wax, earwax, and milk, mammary glands, all modified. So note the 2 types of sweat glands, all right? And then the other modified sweat glands, okay? Did that work out? So the nails, of course, these ones have hard corneum, and they are located where? On your fingertips, for protection. Okay, imagine if your fingertips were just a fleshy end, you'll be hitting them all the time. But your nails really protect your fingertips. Okay, and I can do this because of the hardness of my nails. But if I was just a lump of mass of tissue there, it would be more difficult. So it protects the ends of your, and of course, the nail part that's under the skin is called the root. And usually you see a lanula or lunula, which is the white part that kind of on the bottom here, where the cells are actively dividing. It's called lunula because it looks like a luna. It looks like the moon. Okay, so that's it. And then the nail is resting on the bed on a nail bed, if you will. The skin underneath is the nail bed. And then this is the free end, the nail that grows out here is the free end that you cut here regularly so that it doesn't grow too much. Okay, unless if you are keeping your nails, all right? So the nail body is what's visible. Then the free end, of course, is the end. So there's a bunch of nail matrix and it's full of hard keratin. Okay, so nails, I just need you to know they protect. And the lunula is what I was talking about, so-called because it looks like the luna. looks like a moon. And sometimes you can really see it. And then the cuticle is down here. All right? Okay, so that's it. This, what they call, is the lunula. From the moon, because it looks like a moon, you know, crescent shaped. All right? So integumentary system functions, we're kind of sort of repeating now, and we're grouping them into, so we know that it protects from UV light and abrasions, the skin, and the layers do that, and then prevention of entry of bacteria, okay, because it's layered, the keratinocytes as well, dehydration prevents dehydration, and there are also cells, the Langerhans cells, and so forth, that and macrophages in the dermis and as well, that will protect against microorganisms, and of course help regulate body temperature. We know that, and the hair as well protects against abrasion, UV lights. Okay, that's why we have a lot of terminal hair on our head. It's funny that when you become bald, male pattern baldness, it removes hair on my sunny side where I really need protection from the UV. You know what I'm saying? It's maybe one of those jokes from God or whatever. If we lost hair here, it would be better. And we have a bunch of hair on here because then I need the protection from the sun. Okay? Because hair does that. Anyway, that's okay. It's my complaint, you know, because so nails protect, of course, all right? And then sensation, of course, the macro cells and all the touch receptors for heat, cold, whatnot, pain, pressure, you know, and so forth. Okay, and we got the macro cells. So I mean, you know, we're just kind of sort of wrapping up the functions here. Temperature regulation, the hair, all right, the sweat glands involved in temperature regulation. Of course, so these two, when sweat evaporates from your body, that's how you cool off. Because the heat that you're producing will cause the sweat, the liquid, to evaporate off your body. And that energy that is involved in heating the air to a gas, that's how you lose the heat. Right? And then, of course, vitamin D production, more about that, you know, with the UV light. Okay, and then 7-dehydrocholesterol. Excretion, very minor part of skin, just a little bit of uric acid, urea, ammonium, but those are taken care of by other organs. And this is a picture just showing erythema, right? Like blushing and so forth, or when you are flushed and you're hot, they become more superficial, so you lose more heat, and they shrink pretty much, and they become more deeper, the blood vessels, and you lose color too with it, and you lose less heat, okay? So this is the erythema part of things. This is one of the ways you can alter skin color physiologically, all right? And then now we've got the skin cancers. I'm going to kind of quickly go through these, but I just want you to know the cell type that's involved and whether it's malignant or. So if this one is not malignant at all, the least malignant is in the basal layer. That's why it's called the basal carcinoma, because the basal layer, all right, and proliferate and invade the dermis and hypodermis, because the basal layer is right there on the thing. Slow growing, and it doesn't metastasize, which means it doesn't affect other organs or spread to other organs. Cured 99% by excision, removing it. Okay, and then we're getting a little bit more malignant. Squamous cell carcinoma arises from keratinocytes of the stratum spinosum, because they're kind of squamous shaped. Stratum spinosum, they're beginning to become that. So arises most from the scalp, hairs, lower lip. Okay, and it grows rapidly and metastasizes. If you don't remove it, it means it will affect other organs. Because that's when cancer is dangerous, when it goes to other organs, and then they grow cancer. Oh my God, there are more. Okay, so melanoma is the most malignant. All right, it affects the melanocytes, and remember, the melanocytes produce the melanin that protects you. So you know it makes sense that this is most malignant, and it's resistant to chemotherapy. So you have to use immunotherapy. Okay, and it metastasizes very quickly. It takes goes to other organs. Okay, so melanoma has got this kind of the ABCD, the asymmetry. It's not asymmetrical. The shape of it, it's about 6 millimeters, like a pencil eraser, and it's got a border that is inhibits indentations again, and the diameter is 6 millimeters. So that's the asymmetry border. Color is dark because of the melanocytes. It becomes very dark and brown. and black in diameter, of course, 6 millimeters. Treated by excision and immunotherapy. Why? Because it's resistant to chemotherapy. Right? So I think the burns, there's degrees of burn. First degree, just the top layer, and then it includes the bottom layer, the dermis, second degree, and then this one, full thickness, it goes all the way to the hypodermis. Okay, so that's all there is to it. And the rule of nines, I don't really need you to kind of know this, but it's just a way surgeons measure area of the body by dividing it into multiples of 9%. So that when a certain part of your body is burnt, they can estimate, oh, but this is much skin is needed for grafting purposes, for treatment. Okay, so just know about the rule of nines and that it's used to measure, the area of skin that's burnt. And that in young kids, this ratio is kind of skewed because kids have bigger heads than the body, compared to the body, okay? All right, and then that's that. And this is what happens when you get old. Wrinkling and so forth because of loss of elasticity and intolerance of cold. That's why you always throw a grandpa a blanket. Yeah, because their skin is now thinner, and they don't have all the protection. Their sweat glands are not, everything is kind of slowing down when you get old. Okay, melanocytes are no longer producing enough melanin, and you get, more cancer, skin cancer, and so forth. That's why you get older, you get cancer. Thank you guys, appreciate it. We'll see you in a little bit. And I'll give you 5 minutes for the lab, okay? We'll start at 5 past.